Now that we understand how the breadboard works, we are ready to actually go ahead and wire up our microcontroller to bring it to life. And we start by inserting it into an open area of the breadboard, and we will proceed to actually start wiring up various pins of this microcontroller. But to do that, we really need a guide. We need to understand what each and every pin of the microcontroller is there for. And to help us, we need to look inside the manual. I printed out a page of the datasheet of the particular microcontroller that we are using. And as you can see, it somewhat resembles the chip in how it's actually illustrated here. Next to every pin, you see some text. And the meaning of every one of the pin and the text that's next to it will become clear as the quarter progresses and as you are introduced to more aspects of this microcontroller. Today, and for this very first project, there are a few of the pins that are really important. And those are our power pins. So if you look here, you see that pin number 10 is VCC, and pin number 11 is ground. 10 and 11 are the two important terminals that we need to connect. This is how we will apply 5 volts, a power source of 5 volts to our chip. What you should recognize is that on this particular chip, there's actually more than one set of power pins. On the other side, there's also a ground and an analog VCC. Don't worry about the difference between analog VCC versus just VCC. For now, just assume that 30 and 10, pin number 10 and pin number 30, are the positive side of our 5 volt supply, and pins 11 and pins 31 are the negative side or the ground side of our power supply. So we need to make this connection on our breadboard. There is another group of pins on this microcontroller that we will need to wire up, and those are pins number 9, 8, 7, 6, and 5. These pins are important because they connect to the programmer, and this is how our programmer is able to take our software, our application, and download it onto the internal flash of the chip. This is the programmer. As you can see, it has a wire harness that gets connected to the pins I was just pointing out to. Finally, we will be using one of the general purpose digital outputs of the microcontroller to power the LED. So pin 1 would connect to an LED. And this is how the microcontroller can be programmed to turn the LED on and off.